Everyone, good morning, good afternoon, good evening. I think we are waiting for a few more folks to join in. We can give them a minute or two and then we can start.
I know, right? This is confirmed.
Hey Sundar.
Today the first day, today the first day I'm joining in.
Oh, okay, okay,
So, okay. So I'm a data scientist.
okay.
And so my whole requirement for this course is I'm MLOps AW. So in the beginning of the hour, that's what my organization is currently. So I want to get some
Your
hands
voice
on.
is breaking a little bit for me, Santosh. Your voice is breaking a little bit for me. Yeah,
Can you hear
but
me better now?
I guess it's slightly better. Yeah.
In the need of the hour, my organization is looking to scale up on AWS.
Okay,
The model, big model. So I just
okay.
wanted to know, like, if you would be covering MLOps with AWS primarily, along with other clouds, or how is it?
Yeah, absolutely. So Santosh, I think so. In the yesterday session, we have announced that no, we'll do the like MLOps with AWS as well as Azure. And right now we are starting with GCP because the fundamental concepts and the materials that have been prepared are on GCP. But we'll soon having the demos on Azure and AWS also. So the thing is the concepts are same if you go on any cloud, but the thing is demos can change. So only slide of the services or maybe like some functions, some coding styles might change, but like at the background
So,
things will be still the same.
so basically, the material which you have is on GCP, what will be covering. When it comes to demo, we'll be using both AWS and Azure.
Exactly. So it's not also the material is also it's not on the GCP. Like we have built the the slides and everything, or maybe any reading material that we have is the like cloud agnostic. But there are some things that are catered with GCP. Say example, services like Vertex AI. So we were earlier thinking, we can cover two clouds, that is GCP and Azure. But later on the demand of people, we got to understand, okay, people are working with AWS also, and those who have enrolled in the course and they have requested, so we'll cater to their demands, and we'll see a demo, like demo sessions on AWS as well, to make you comfortable on that cloud. So we'll just start with the GCP, and in a session or two we'll be having some confidence in GCP, and then we'll be moving on with the other clouds as well. Okay. Yeah, it's all about so having, so at the back end, if you if you understand whatever cloud you use, it's basically a machine. Or maybe if you are using some managed service, every cloud will be having something similar managed service. So you don't need to worry about it. You just need to focus more on the learning the framework, how to think about it, how to work on that. So that is the main fundamental things that you want to learn, and rest coming on the cloud, or maybe which service you are using, that's a secondary thing. So you don't need to worry much about it, but we are there to solve your doubts. If you have any specific doubts right now, maybe after the session you can connect with us. Okay. And we can solve your issues in the offline as well, or maybe like if there is any specific requirement, we can handle that in our next sessions. Okay. I think we have the
Yep.
forum now.
Bhuvesh, I have I have one question from my side.
Yeah. Yes.
Yeah. So I have a DevOps experience along with AWS and Azure almost 8 to 9 years to say. So will it
Okay.
be means adding to advantages here means in the MLOps uh, out of syllabus, so will be in the DevOps only, right? I see in the syllabus. So DevOps methodologies are covering here, right?
Correct.
That's what
Correct.
we are using, right? So those.
Yeah, absolutely. So it will be a lot of help for you to, have the basics, or maybe, the fundamental concepts such as CI, CD, or maybe
Yeah, I have advanced level concepts and working on that as well. So,
perfect.
okay.
Yeah, so you will be having an upper edge over these things, like, which normal like software engineers or the other people, those who are coming from different background, they might not have. So you can focus your time and energy on the concepts that you feel that are new for you, and whatever you feel like it's relevant, you have already done. You can skip that part and do the demos for other sections. And at the end of the things, you can combine everything, and you can prepare a single project which is showcasing all this.
Okay. Good. Other thing, Python, you need to learn advanced level, right? Basics, I know Python.
No, yeah, not advanced level. So the Python
Mm.
that we will be using is fairly, I would say, basic to intermediate. We are not, we'll be not using any of the advanced level concepts in
Okay.
Python.
Yeah.
So
In that case, I'm good with that. Yeah.
yeah, exactly, exactly. So, whatever Python we are using, right? If somebody is having any issues, you can connect with us after the session or something. Then we can guide you accordingly. You know how you can pick up these things, because the Python that we are using is not that like a higher level. It's very basic level, and you can easily understand. And the scripts are very very simple. So the way we are moving, right? So you don't need to worry anything about the Python as well. Even if you have a very basic knowledge, that's very fine. If you don't have, then you might have to spend some time learning that, but yeah, I think you should be good in a few sessions.
Okay. Thanks, boy. I got cleared my doubts.
Okay, I think we have most of the people. uh, Let me check if anyone else is joining, or we are waiting for someone. Okay, I think sure, we can start. I think, let me know once you are able to see my screen. So I'll start from where we left yesterday. So this was, I think, the slide which we saw yesterday. And for those who are have not attended, last 2 or 3 sessions which we have covered, you can check the recording, or maybe go through the concepts. We'll try to revisit some of them, but few of the concepts, like what pipelines are, what are the ML, operational challenges. There were multiple things that we have covered, so I cannot go and cover everything now, because it's been like 2 3 sessions that have happened so far. So you can talk to the coordinator and get the recording for whatever sessions you have missed so far. Okay. So, but in a brief, like I'll recap, what has happened so far, and like yeah. So here is the machine learning life cycle, and we have seen different level of maturity in the ML processes. That is the ML level 0, MLOps level 0, MLOps level 1, and MLOps level 2. Okay. So let me go to quickly, recapping all of the things. So ML level 0, that's a manual manual process. Like everything is happening in a manual way. You are having a handoff. The script is written by a data scientist, or maybe a developer, and then the final, like an artifact, are given to a ops team. That's to the right, and then the model serving happens. Okay, and that this is how, like there is no continuous deployment, lack of active performance monitoring. So there are multiple issues which we saw. So we moved on to advance to the MLOps level 1 pipeline. So in the level 1 pipeline, you have the source code is like put it in the source repository. You have a pipeline deployment which is then automated using this orchestration, and then you have a model registry, you have train model, put it on the model serving, you have prediction, and then there is a performance monitoring. So we look at this as well in the demo today. If if the time permits, we can look at the performance monitoring, but today what we are planning to look at is the automated pipeline. Okay, so we'll go into the details of the code, and how this thing has been built, and how this thing, prediction service is built, how performance monitoring, how triggers are happening. Okay, so all of these things we'll look in the demo session today. And MLOps level 1 pipeline, as I mentioned, we have seen it. And so right now we'll be working on this part of it. So the down, you can see, right? We will, so this has to be worked out. So this we have not yet presented anything. Okay. And then talking about level 2 again will contain CI, that's a build, test, and package the pipeline components. Containers will be built, it will be stored into the container registry, and then there will be continuous deployment of the pipeline, which will be happening again on the orchestration part here. And then all the things will be following along. So as we saw this machine learning life cycle, so we were looking at different parts. Okay, like what exactly happens and who is responsible for what things. So here ML development here, which data scientists are mainly responsible. Other than this, if you see all other part of it, mostly the ML engineers, MLOps engineers, these guys are responsible. And there is a central layer, data and model management. This is again governance and everything is done here, so that entire all the teams in the business, in the engineers, product managers, everyone has the access to here, and required access is given to the people. Okay, and then everyone is also connecting with this thing. So this is a high level overview that we saw, and this was one other view that we saw yesterday. Is like ML development is happening and the code and config is stored, and then the training operationalizing is creating a training pipeline, which is then able to we are able to continuously retrain or train the models, keep the registered models in the model deployment, and everything is connected with the data and model management. If something goes wrong, like a registered model is not that great, the testing is failed, you can go again and do the ML deployment development. And then, like, this is all we saw yesterday. So if there is any specific questions you have, we can ask like a question one, like one or two questions here. Otherwise we can move quickly forward to the demo. I think we are good. So we'll be looking at what parts, I'll tell you. So we are looking here, the node from the notebooks we'll be looking together. So today we'll develop on the notebooks, and then we'll have our pipeline components in the Vertex AI pipeline. So we are not actually doing this part right now, but we are doing this part and this part. So I'll be taking demos in bits and pieces, and then we'll together build the entire this demo together, like in a later session, once you have a comfortability with all the different services that we are using, all the different things that we are using, then we'll combine everything and put it into a like a jigsaw puzzle together. So yeah, I think first we'll cover the ML development. So ML development concerns the experiment and developing. So it's a robust and a reproducible model that we are producing, like a training pipeline code, or maybe like there are data pre-processing, like data pre-processing, validation, testing, data split, whatever, like it's included, model evaluation. So at the end of the process, we need to have an end-to-end pipeline. So this is what we'll be seeing today. Okay, you can read it carefully, like what all things we are going to do is check the data. Then there has to be some work from the data scientist, so that we are not actually doing 100% of it, but we will be trying to replicate it, because the data scientist does the data discovery, they select the model, and whatever they do n number of experiments. For us, we are not going to repeat that thing, because again that is going to be done by someone else. So we don't actually care much about that as a ops guy, or maybe like the person who is willing to deploy all the models. That for you the model will be more like an artifact, which is produced by a data scientist, and you need to understand the metrics and everything, how what data is kind to go in. So that's what we'll look at it. So in a nutshell, like this is what the problem will look like, a data engineering problem where you have already a data set. Then you have this is the experimentation and prototyping which is going on. The final thing we'll be having a pipeline. Okay, so we'll look at the pipeline today, how it is formed, and we'll go from the level 0 to level 1. Like we'll slightly move from this level, like the level 0 to level 1, and we'll put the train model in the model registry, and we'll track the metadata in the artifact repository, and the parameters, metrics, everything we'll track. Okay, so I hope you are clear till here, and we can go quickly on the demo, and once again we can come back here. So here is what we saw as a pipeline. Okay, so this is the end product which we want today to show. Okay, if you go in here, if you see, the end product is implemented training pipeline. This is our end product today for our ML development task. So if you see, like the first task is ML development. So here we are having typical the assets that are produced. It's a source code, and few configuration workflow. So we'll see all of this, uh, and we can ask any questions if you have in the middle or maybe like at the end of it. Okay. So I think we have walked this through like the Vertex AI. We have walked through the pipeline and in the left sections, whatever sections are there in a like brief overview, we have already shared in the earlier sessions. So if you those who are new, you can like wait for some time and then you will have a good idea. Otherwise, you can look at the training sessions earlier to have a detailed idea. But we'll definitely cover this once again in a detail. So the first, component is our uh, in the training pipeline is the download data. So in whichever ML problem you are solving, right, the key important thing will be the data. Okay. So the first thing will be either you ingest your data from your data lake, you ingest your data from the data warehouse, or maybe there might be some external sources. So this is a very simplistic example which we have taken right now, but if in the real world there can be n number of different components which is like pulling data from and different sources. So there can be something called as a on-premises service server, which is writing data in a database. There can be a transactional system. There can be a warehouse. There can be a data lake. So you can imagine like there are n number of components which are taking the data, and then you can fuse together in a single data set. So this is what we have done. So for the simplicity of the understanding, we have created only one data source, that is our bucket. So this is our bucket. So imagine like somebody is doing the data work for us, and they are putting the CSV in our bucket. So the bucket is nothing but in Azure it's blob storage, in AWS is also having similar like cloud bucket, and GCP we have GCS. So these are the kind of bucket. I can show you what bucket is. Quickly going onto the console, showing you what the bucket is. I think you must have seen like buckets in your work or maybe in your previous experience. So there are multiple buckets you can create. So it buckets as a folder structure, like here we are storing our models. Here we are storing all our CSV, the configs, and everything are getting stored here. Okay, and the pipeline route will be here. All the pipeline related information will be stored here. Okay, so this is how you imagine a bucket, and you see all of the things here. So and bucket can be multi-region or a single region. So the thing that Vertex AI has, if the say example this thing is running in US Central 1, right? So you have to keep the bucket in the same region or multi-region. You cannot keep like the bucket in a separate region, and you cannot run a pipeline in a different region. Okay, so this will not going to work. Okay, anyone has some questions or something? Manike, you have any questions?
No, please go ahead.
Okay, thanks. Okay. Yeah, I see like okay. So we have the data here, and then the data is finally if there is any pre-processing that has to be done, it can be done here. So in the pre-processing part here, we are doing training testing split. So in a data science environment, you would be knowing like typical data science problem. You do the train validation test. If you don't know, it's a very simple concept. The reason being, for a data scientist, the problem is to simulate the real world. When we are training a model, if you understand like what a training a model is, so there are multiple kinds of models. So we are right now talking about supervised learning. So supervised learning means we are providing the label of the data, and then we are saying that, and the problem that we are working is a bike demand prediction. Say like a given time of the day, given like all the information of an hour, we are predicting what is the bike demand in a particular place at that point of time. So that is the basically it's a demand prediction problem. So we might have multiple inputs. Okay, say example, we have a time and the hour of the day. We have weather. We have other things like we can see in the data set what all things. I think some 10 columns are there which are there. I think this is the column. If you can see, season is there. So everything is encoded in the number format. Okay, like a season will be 0 1 2 3, like that. Four seasons are there. So 0 1 2 3. Year will be 0. So if we are starting, like we are having few years of data, like the first year will be 0, second year will be 1. Everything will be starting from 0 year, because we are working in a numerical setup. Okay, the month will be again from 0 to 11. The hour will be again from 0 to 20 23. Holiday will be either 0 or 1. So it's a holiday or not holiday. Okay, weekday, it's a weekday or no, it's a weekday or weekend. So either or. These are boolean. So all these are boolean columns which we are seeing 0 1. Okay, working day. So there are two things. Either it's a weekday and a working day. Okay, because that makes a difference. So since we are demanding, we are predicting the demand of a bike, we need to understand if there is a working day or not. So these are all the parts where data scientists work in, and they work with the business folks to understand which columns would be required, which features will be required. So we call this as features. So this is nothing but a feature. Okay, everything is called a feature, and we'll quickly see on the start. Okay, what exactly data we are having here. So the data that we have is it's here. Okay, this is our CSV. So this is containing some. Let me check how many records this is having. So this environment is called as Jupyter Lab. For those who don't know about this and they have missed some sessions, so this is the environment, our local environment development. This is created here in the workbench. Okay, in the Vertex AI, if you go here in the notebook section, you will find like a workbench. So this is same in the other clouds also. Okay, so if you go ahead and go on the AWS, you have a SageMaker, you have a SageMaker notebook. In Azure ML, you have a Azure ML notebook. So similar thing. So this is nothing but a machine, like at the back end, which is again configured by us only, and we have mentioned what environment we want. So these are some preset environments that we are using right now. You can custom build your own environment if you have your own image. Say example, if you are working in an like an organization, they need certain packages, so you can build your own container and put it over the machine, and you can reuse that same container for everyone. For us, we have used the pre-built environment that these guys have given. So you would want to create a new, and then there are some environments pre-built. You can use this Python, TensorFlow, PyTorch, Kaggle, everything, like they have given whatever you need. Other than that, if you want, you can choose the advanced options and you can look into that. So we have already seen these things, but again, if you would want to do it yourself, that's you are welcome, and you need to try this, create new, and just fill these things. Go to advanced options, choose whatever things you require, and then you can move ahead. Okay, you will get a machine for yourself. In the machine type, you can select whatever machine you want. There is ideal timeout, or you need to do that. So this whatever you want environment, and so environment also, you can create a post startup script, like whenever the machine warms up, you can run your own scripts, such as to cloud, if you want to run any command specifically or something. So all this facility is there. Okay, for as a DevOps person, you will be already knowing this. If you are not familiar with any of this, you can ask any questions on this if you have.
Yes, Santosh here. I have a quick question. Right.
Hmm.
So I understand this is the notebook you're basically sharing, which basically has the code for the model training, like that, right? I'm correct.
Yes, this will be having code for everything, not only like model training, but yeah, for now we are talking about model training pipeline, so it will be having that.
This piece of code which you are showing here, you have implemented in the Vertex AI, that flow which you had shown, right? That's how we have done it.
Yeah, this one, right?
Yeah, this one. Yeah.
So this one is a Kubeflow pipeline. Okay. So we have used open source platform that is a Kubeflow. So Kubeflow can be used again on any cloud different machine or maybe on your own personal machine or anywhere. Okay. You need a cluster, like even it's a single node cluster to run this. And right now we are running this on Vertex AI because it's a serverless. It's a managed version of Kubernetes. So we are not creating on our own. So that's less overhead for us.
Basically, these two are two different things. Notebook is a separate thing, and this Vertex AI, the pipeline is a separate. We are just walking us
Exactly.
through. This is
Yeah, 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 yeah. We will look at the detail in today, right? How will we push the things and how will we submit the job? So, and what is happening at the back end, we'll look at it in detail. I think it will take close to 2 sessions to understand the entire breadth of it. Okay, after 2 sessions, I think you will be comfortably, uh, developing your own pipelines again. Okay. So, how many of you have got the GCP trial registered? Like yesterday, I had asked you guys to register a free trial. How many of you have done? So I still suggest you guys to go ahead and register a free trial. It is costing nothing, so it is costing zero rupees, $0 to you guys, and that's a free trial like a $300. You can just register and follow along because here in these sessions, if you just come and attend here, so you will be gaining no confidence. If you come and do your own demos along with me, you can open a screen and you can quickly do what I am doing. I can share you the materials as well, and I can share you the links of the notebook. You can go and try on your own, like after the session, during the sessions. So it will be helping you guys only, okay, to gain more confidence. Do you agree with me, or like any other thoughts you have?
Yeah, yeah.
Cool. Okay, guys, I think so. We'll quickly move on to the thing. So as we saw, I think there is some problem. We'll restart the kernel. So this is the local, this is the Python 3 local. There are multiple kernels that we can have. Okay. So like, PyTorch kernel, we can have our own kernel. So kernel is nothing but, our set of virtualizations done. And, if you have an idea about the background in the data science, there are some environments, like in any different thing, you have a pip. So pip will install, and then you have a virtualization called as conda. So there is a particular thing that is called as so anaconda, that is uh, like a distribution which is having all the basic computing things for Python, and in the machine learning we have this. So this is for Windows, Linux, and all. So the Jupyter lab is using anaconda under code. Okay, so you don't need to worry about any of this. You don't need to actually understand, but I am just sharing it for your references. You can understand at the background what things are happening. And so in the first cell, let's start from the first cell, and I will share the notebook link with you guys. So if you want to try it on your end, okay, you need to try that and let me know like how it goes. We'll share the notebook link with you. So the first thing is like a user flag. Whenever you install a pip install, you can have a user flag, or you can have a system like you are installing for the everyone. So that's the first step. Like we only install for my user. So there can be multiple users on the notebook, but I'll install for my user. The reason being, if you use for a system level, you might need admin privileges, which you might not have. You might be only a single person in the notebook, and like that will cause some issue. That's why we are using a user flag for the safety. And then once we are, having all the things installed, we'll install one more package, that's a Google Cloud Pipeline Components. I think here we can remove this. This was the older version. Okay, so this is there, and then we are restarting the kernel. So once we are restarting the kernel needs to be restarted whenever you do any installation, because the latest, the way you work, like in your Windows machine, you do anything, you do the path update, and then you restart your machine. So this is the same thing. Now we are restarting our kernel, and then we are importing. Right now we can do the import because installation part I've already done. Okay. If you see like Kubeflow SDK will be installed. That is a Kubeflow official SDK. And then there will be some Google Cloud pipeline components. These are again, open source elements from Google. So they have given the pipelines, Vertex AI pipelines. They have some pre-built components. We'll use these components in our demo today. Okay. Then we are checking about the project ID. If project has its own ID, okay, we'll be using this at multiple places. That's why we need to understand, what project ID is. So we'll just run this cell again. And once we have our project ID, we for the the bucket needs to be unique, and the project ID is unique for everyone. For any, if you're also having a GCP environment, let me know. I can share the notebook with you, and you can also run along with me these cells, okay, on your own, and then you can also understand. So the bucket name is there. Like we'll just create a unique bucket name. For the uniqueness, we'll keep the project ID in the center, like in the bucket name itself. Then we are downloading a data. This is our open source data. No, this is our, like, Google has given us this data, and then we are using the bucket. There is some, and then we are downloading this data. This data is downloaded in a zip format. So here it is in the zip format. Okay, and here I've already downloaded the data. So then we are unzipping. Then you are creating a bucket. So if you don't have a bucket, you need to create it, right? So for the first time when you run, you need to create. So this is the command that we are using, gsutil-mb. That is gsutil. This is a utility for Google, talking with the Google Essential Library, and then MB is the make bucket. So this is a CLI. That's a command line. That's why we are, anything that is running on Bash, we need to either put the exclamation, or maybe, like, you need to put like this %bash. By this, if you do whatever commands you put, right, this will execute in a bash mode. Say, like, I want to put these things. Like, I want to put this one. I want to put this one. I want to put something else. Bucket name. No, I want to create like some CP copy or something. I can do all of these things here, okay, in a single bash thing. But what about, like, if I want an inline bash, it's a one single line, we can do exclamation mark. Okay. So this is a process. And I think you might have interacted with multiple different clouds, so all will be having their own convention. So this will be again a CLI. If you're comfortable, you can use the CLI, or otherwise you can if you're beginner level, you can create a bucket on your UI and then upload the data. So maybe, like, you can use this link to download the data zip, and then, but the preferred way is this one, CLI. So you need to always learn all these commands. Okay. Then we'll do the gsutil cp, the normal copy command, and we'll put this everything into a bucket. Okay. And then we are listing the contents of the bucket. gsutil ls. So ls is the list command. Okay. So I'll provide all of this commands and the notebooks with all the documentation with you. So as like, you can run on your own also in your local machine, or maybe like in your Google Cloud. So in your local machine also you can run the same notebook. Okay. So the only thing that you need to install in your local machine is Google Cloud SDK, and you need to have an active project in Google Cloud. So this is how a project looks like. Okay. So this is there are multiple projects that I have. So we are working in the MLOps project. Okay. So that's why we need to have the project ID and everything. Okay. So once we have our bucket, so we are verifying that we have our CSV. That is a required thing here.
Bhagesh, one question. Bucket means what? Like, storage account name, bucket means?
Yes, that's a storage account. A storage account, as in, I'm not sure what you are talking about storage account, but this is what a bucket means.
No,
So
no.
storage.
Bucket means, like, for example, let's say I have one data file, one file. I want to store that file in that bucket.
Yes. Okay.
No, no, no.
Yeah.
Where is that bucket physical location? Like you mentioned dollar bucket name, right? Let's say you have copied file into that bucket. Where it is stored in that bucket?
That bucket path where I can see that.
This here, if you can see, in the cloud storage, in
Mm.
cloud storage, you can go into the bucket. Okay.
Okay, like AWS S3 bucket, like Google Cloud
Yeah,
Storage
yeah,
bucket.
yeah.
Okay.
S3, S3. This is a S3 bucket.
Okay, okay. Yeah, yeah. First, you have to tell that thing, right? We are not aware of these keywords in our GCP environment. What is workbench? What is TensorFlow? What is bucket? What is Google Cloud Storage? We have to we need some knowledge on that. Okay, thank you.
Yeah, yeah. I think I have called it out. I have not called out the S3, but I have multiple times called out. This is a part of a Google Cloud Storage, and here it is clearly written. This is a part of a, like, similar, like how you have Amazon S3. You can transfer your things from any other bucket to this bucket. So yeah, if you have any specific questions, you can definitely ask. I mean, I am trying to like share with you in a way that I can. But yeah, definitely I can be, like, you need more information, you ask me. I can happily like present everything. Okay. And then this can be like regional buckets or maybe like multi-region buckets. Okay. And the regional will be like in a specific region. So it's a one single location. There are multiple zones. So in a bucket there are zones like zone A, zone B, zone C. So in a US Central, A, B, C, three will be there. And then there will be a multi-region. Multi-region, your data is copied into multiple locations. So, and these are public access are like confined, so you don't have any public access. If you want to give, you can give, and the access control are fine grained. So any other questions on bucket? Okay, so I think, hope everyone is clear now on the bucket. Shall we move ahead?
Uh,
Yeah.
Bhavesh, one second. Could you just, sorry, I
No
couldn't,
worries.
little bit, I have some little bit of confusion. Could you just show me how you went for this creation of this bucket?
Yeah, yeah,
Like
sure, sure.
from Vertex AI you went, right?
No. So this can be created on from anything. Here we are using the command line interface. Here is the let's create a bucket in front of you now. So
Yeah, please.
yeah, let's create a new bucket for you now. So we'll use this command. Okay, these are the two commands that you want to use now. Okay. So what we are
So
saying, bucket name.
right now, no, right now we are not able to see anything. I'm not able to see anything because I think it is slow. Internet is slow, I think so. I don't know how it is. Okay, go ahead.
Is it for everyone?
It's bit
That
slow. The screen,
Fine.
everyone is not able to see, or only you?
for
Can
me, it is,
someone? Okay.
the screen is moving very slowly.
Okay. For others, can you please confirm if the like like it is going smooth, or you are also able to see some issues? I can switch the connection if it's on my side.
Yeah, you have closed the screen.
Okay.
In your home screen, Bhavesh.
Yeah. How about now?
Yeah, same home screen. Now I'm seeing your note.
And now I'm seeing your desktop screen.
How about everyone? They are able to see the notebook or still the desktop screen?
Notebook
Yeah,
you're saying. I
now
think, yeah, you're okay, Bhavesh. I think for that guy having some internet, is home internet some slow, I think.
yeah, now I'm seeing your notebook, Bhavesh.
Okay. Yeah. So let's create a new bucket here. So here we are having the multiple buckets. So that's what we'll do is right now ignore everything and then put a, like uh bucket test MLOps hyphen 1 2 3, like whatever you want to put some name, bucket test notebook. So we are developing it from a notebook. We are giving a name. The name should be unique. That's why I kept a pretty big name. Okay, so that nobody should be able to have a similar name. So let's see in the bucket we have created a bucket which will be able to refresh. Now you can see our bucket has been created, and by default it has created in US and a multi-region because I have not specified. You have to specify a region if you want to. Okay, if you say MB bucket name hyphen hyphen region hyphen US Central 1, you will have to specify this 1A. Okay, so this way you will have your bucket in US Central 1. If you specify US Central B, it will be in B. If you say US West 1 A, so it will be in a US West 1. So whatever region you specify, it will be created in a specific region. But for our use case, we don't need to, because we might work in any environment or any region. That's why we are creating it multi-region, so that I can have my things deployed in any region in entire US. Okay, that's how we are creating. So I hope you got it clear, like how you are creating a separate bucket for yourself. That's the main reason, I want everyone to have the working on your own. This notebook, you can take a notebook, I can give, you can use the terminal to copy things, and you can work on. So I would like to see everyone doing the same thing, so that if there is any challenges in understanding, we can do that. Okay, otherwise it will you will feel like things are going smooth. Okay, let's quickly jump on to any questions, confusion so far.
Bhavesh, I'm still having a small doubt. I understand that you're building your. Bhavesh, can you hear me?
Yeah, I can hear you, Santosh, very well.
So, in the Jupyter Lab notebook, you're building your training pipeline. Understand that you're downloading the data, uh, training a model, and stuff. So,
Mm-hmm.
you embedding this particular notebook which you have created in the first
Yes.
flow which you showed. Is that what you are going to do? Because I want to basically connect. Because first we saw some flow, right? Then we jumped into the Jupyter Lab notebook. I want to understand the connection between.
Yeah, yeah, we will be. So that's the end product. We will be going from scratch to building that. That's a long way. At least minimum, 1 to 1.5 hour session is remaining to get onto that flow. I just showed you that, you will be landing it there. How we are going to go there, that's a long process. We are going through that. So we'll go the step by step, how a data scientist work, how a data scientist give a model. Like we'll go everything, with that notebook, and then we'll create our own pipeline from scratch. So you will have to go through everything line by line. Okay. So
On
that
a
will
very
take some.
high level, that notebook will be embedded in the pipeline once you create this notebook, the code in
No,
the
no,
code,
notebook
right?
is a
So
separate thing. Pipeline is a separate thing. Don't confuse between these two. Nothing is connected here. It's the only thing it's connected. We are pushing the code in the notebook. It's more like, this is your machine. You are putting the things on the cloud. So instead of your machine, you're working on a cloud machine. That's a VM. Okay.
yes,
The VM is having an interface like a Jupyter notebook, which is familiar for data scientists, ML engineers, MLOps engineers. We are familiar with that notebook. That's why we are using that kind of a thing. But there is no limitation that you can do only that. So, like a way you write the commands from your computer to the cloud, similar way we are writing it from notebook to the cloud. If you see, if you have some confusion, I can show you the slides as well. Okay, slide deck. So where we have shown, say example, I'm talking about this slide. So this one, right? There was some slide which we had shown you. Okay, let me take the time. So this is the experimentation notebook is then, and this vertex pipeline is this. These are two different services. So this is nothing like connected. You are just configuring from this notebook. You are putting it here. Okay. So for the simplicity sake, only imagine two boxes. So this is drawing arrow towards this one. Okay. Yeah. So don't worry about it. We'll cover everything in detail now. Just hold with me and watch the things, and you will be able to do this on your own. And I'll recommend to get this notebook and GCP account to work on this. Okay. So first thing is will do the import. The import statements, you are importing multiple things. So like a data scientist is using different libraries. So you might have heard pandas, numpy, scikit-learn, no? All these things. If you are slightly familiar to data science, these are all very, very basic libraries. So pandas is nothing but using for a data frame. Like we have a pandas data frame, which we are using. And then I think there is some connection issue with the Jupyter notebook. I'll have to refresh this, but yeah, let's keep a duplicate tab open. Yeah, fine. So like we have saw pandas, numpy, it's very basic. If you don't know any of this, let me know. Then I can share some links with you. You can go through what is this library. There are some Google Cloud libraries which we are going to interact with their own services, Google Cloud services like storage. And for integrating with Vertex AI, they have known a library called AI Platform. So with all the different Vertex AI services, you need to use this AI Platform library. Okay. Then we have sklearn. Sklearn is nothing but it's a like a ML framework, like machine learning framework where they have a bunch of algorithms. Random forest regressor is one of the algorithm which you use for regression. So regression is nothing but you have certain data points that you are giving. It's a supervised learning where you have a certain data points which you are using, and you will be uh, like taking a new data point and then predicting on that. So basically, if you Google like regression random forest, so the random forest is a very famous algorithm. So it will come, what is the random forest? Random forest is predicting numerical values. It combines prediction from multiple decision trees. No, all that. You don't need to go in the depth of it. Okay. For you, the machine learning model is more like an artifact. You just need to understand what kind of algorithm is used, what kind of framework it is used, like a metadata. Okay. So you don't need to worry into much detail and depth of it. That's the reason I'm not going pretty detail. Otherwise, this will be a separate class. And so this is a pretty big concept, like what regression is, and then supervised, unsupervised learning. But we can, in a high level, what we are doing is a supervised learning because we are having the C and D variable is what we are predicting. So this is the count of a bike for a particular given of hour. So if you can see 0, 1, 2, 3, 4 hour. Now what we can see is we can see head 20. So data, this is our data frame, data, and head is looking at the top of it, like top records of it. So let's say we are pulling a record from our CSV, which is on our bucket. So the URL will become like bucket name / our.csv. Okay, and then we are doing PD, that's the pandas dot read CSV from this URL, and then we are doing data.head. So this is nothing but give you 20 records straight. Yeah, I think the this got errors. One second. I think the connection has some issues or something. And let me try to do this right over here. Okay. Let me try to put this URL. What is the URL? Okay. Yeah, this is our notebook issue, right? Yeah. So in the meanwhile, we changed the bucket name for showing you, right? And I got a error. So let's okay, report. Then let me close this one. If you see our new bucket, it doesn't have anything. The problem is with that bucket. So what we did is we created a new bucket and the bucket name changed. So we need to again, revert back to our original bucket name and then list the files to confirm that we are having these files. That's why. So this is a problem. Now, like visualize the data, what it is exactly. So we can see, this is the instant is nothing but, row ID, like 1, 2, 3, 4, 5, 6. And then this is the date of that day, season, which season we are having, year, which year we are having, month, hour, if you can see, like you will have a 24 hours timeline. So if I see like in 20 hours, it's 0 to 19. Holiday, it's 0, 1. Weekday, it's, 0, 1, 2, 3, 4, 5, 6, like that. Working day, it's a 0 or 1. There are these columns are there. So similarly like that, temperature, temp, humidity, wind speed, casual and registered. I'm not sure what exact these columns are, but registered is how many number of people have registered and the actual bikes they have taken. So if you see that this number will be highly correlated with your count. Okay, if you see like it's very much correlated with this. So this is a kind of a data that you have. Okay, and our job is to predict the count. So that's a given that all these values, you have to predict the count. So if you see from left to right, we have all the values which we need, and by that we have to predict a count. So how does this happen is, we will not go into the detail of how the regression happens. For that, for us it is a black box. Like, there is some algorithm which is taking in this data and which is predicting this output. We are not going into the detail right now. Okay. So let's say now you have a like now you have our like training data ready. So this cell is not important right now. Let me delete it. This is all I was doing for my purpose. I can show you this cell again, but yeah. So right now we have our data. So this is our modeling columns. So modeling columns is nothing but you are like from this column you're reducing this one column instant and the date time. These two columns you're removing. So we are filtering. This is known as a filtering process. I can write the comments for you using pandas data frame. So this is nothing but this is a filtering process. So if I remove like a 2-3 columns more, it will filter that also. So this is like a data scientist decides what columns we need to use for our processing, for our algorithm. So all this is basic on their experimentations. Okay. Once we have our experimentation done, we will fix this column and we'll get this final columns with us. Now, if you see the data, let's put our data again. So the shortcuts that I'm using is Shift Enter, or you can run this from this cell. So you can use this one. Okay. Now I'll get data. Data is like 17,000 records. And then now if you see like the first two columns have gone. From here, the first two columns have gone. This is a pre-processing. Okay. And then we are dividing this into a training testing split. So the reason that we need our split is because we need to simulate like a real world. Okay. And then we need to train on a portion of a data, and we need to test on a portion and do the validation as well. So validation is nothing but when you compare different models, we use this validation. Okay. So we can again, you in the pipeline you must have seen like there were few of the data sets that were produced. So these are the same, we'll be doing this same thing. Okay. So given a data, we are doing data and then sample. The fraction is 1, random state is 42. So these are nothing but the seed, like to reproduce the same values, we are giving all these inputs. Okay. The random state is 42, and then we are having this like training into length. like the number of records. So this is nothing but, if I show you here, let me run this and then I can show you this. So 13,900 records will be put into our train. Then after that, the rest of the data will be split again in the 10 percentage, like roughly around, 4,000 data left. So out of which, like, you will be having rest of the data into train, into test and validation. So if I show you the length of this, so we call dot shape object. So 13,900 records with the 15 variables. So 15 columns. This is all the columns. Same goes with the validation. Let us see validation. 1700 records. Test also will be the same. 38 records. So we are having the splitted data. Now we are using the target count. So the target column has to be identified. So in the machine learning, if you have a supervised learning, so you need to have a one target column. If you are having a tabular data, okay, tabular data is nothing but in a this table format. So you can see this, right? In the table format, we have a data. So this is known as a tabular data. Okay, and then we have a count. That's a column which we are predicting. So we are dropping this column from our dataset, train dataset, because we don't want the model to see this output, right? So what will be the like help that the model is doing then? If we are giving this to the model, then there is no output, right? So that's why we want to give this as a Y train. So for a machine learning use case, you have a X and Y. X is the feature set, Y is the resultant set. Okay. Now you split the things and put it into this. Like we split the columns now. 14 columns go in train, one column go in Y train. Okay. So now you can see the shape of the X train became 14. Okay. Now we got the 14 column. The one column is outside. Let's see like X train now. It's a 14 column. Let's see the Y train now. It's a one column. Okay. And this is our ID. You don't need to worry about this. This is a memory ID. So this is nothing but if you just say value will only show array. This is our final array. Okay. That was with ID. So you don't need to confuse. This is a one dimensional array. Okay, like a list. In Python, list, right? List is a like list of values 1, 2, 3, 4, 5, 6, like that. So and what is the shape of it? We'll see this. You see the length of it, it will be the same. 13,900. So it's the same. This is not needed. This I had done for putting it into a test data into CSV. This is not needed. This is also not needed. This is the next step. Build a model. So you might have heard like building a model, fitting a model. So this is nothing but you are using a random forest regressor, and then you are fitting that model, X train and Y train. We are putting it here, and then we'll run this. So this will give us the output, the model output right now, but the model will be in memory. It will be in our computer memory. So we need to store it somewhere. That's why we will store the model in a GCS path. That's a storage, Google Cloud Storage, like S3 bucket. Okay. And then we will predict the validation. Using the validation data, we'll predict some, like we'll evaluate this model. If this model is good enough or not. Okay. Now you have all these metrics. Okay. Now what does metric mean is the MAE, that's a mean absolute error. Like, in the absolute terms, if you are having 100 bikes and you are, having a like one, so this is on a absolute, like it's either minus or plus. So we are having like if there is a prediction of like say 16, you have -1 or +1. So either or. It's like we are in a range of 1 one bike issue, one bike error, like a error of one bike. That's a mean absolute error. So that results into a 0.5 percentage. If you see like in a, so 0.5 percentage is like 0.5 percentage. So on 100, if you see, it's 5. Okay. So basically, if we are having 100 bikes on an average, we are predicting 5 bikes in error. Like, either you will predict higher or maybe you will predict lower. So this is, again the same. So these are nothing but, way of showing a business person. These are metrics, like it will help them. So again, you don't need to worry much about this one also. Like you will be uh, given this by the data scientist, the how you create, and you will just take this code and run it into a pipeline. So our sole purpose is, so the entire thing that you are seeing here, right? You don't have to write this thing anytime. So I am just explaining it to you for the process, how a data scientist does the job. So you have to just use this and like package it into a container and put it. So that's your only job. Okay. Any questions on this? I'll pause here for a minute. Seems like no questions here. So was it a like a bouncer, or like you didn't understand anything, or you understand something out of it? What is the data scientist process? And we went through model building entirely from scratch, and you took the data set, you built a model, you could predicted, you took the evaluation.
It will take some time because bit
The data science part I understand. So,
Yeah, I can understand. So this is a one-time process, okay? So you don't need to worry about writing this code. So you just have to learn about the steps. Okay. The step number one is like loading the data. The step number one is like loading a data from somewhere. Okay. The step number two is pre-processing, doing some pre-processing. So you just need to ensure that the proper steps are there, and you don't need to actually worry about this code. So nobody will be asking you to write this code, and nobody is expecting you to know all of this code. But yeah, this is like a very basic code. So if someone asks you, you can like try to do that. That's not a problem like that. But there is no compulsion on writing the code, fitting the model. This is never like not in your job role. So nobody will be asking you to do this thing. Okay. And then there will be a evaluation that we are doing finally. So this is our main, like where we are now. If you remember, like there was a manual handoff. So this slide, sorry, there was a specific slide which we saw. Yeah, this one. So right now we are here. Okay. So we have done all of the things: manual data preparation, model training, production model writing, train model. We have a trained model, and now we'll do with the serving team or the ops team. Here is the main task now. That's why I want. So till now it is only a like a data scientist work. Now the actual work for a ML engineer or MLOps person will come in. Okay. So I will draw a line here. We'll say markdown. Okay. So work for MLOps. So entire thing, this down which we have is work for MLOps engineer. So you take the model as output. For in the start, whatever you have done so far, right? So you don't need to worry about it. It will be all like done, and you will be starting your work fresh from here. Okay. So you will get a model path. So the data scientist will have to save his model on a some path. That's a again a GCS bucket path. So let's say, for an example, he's writing the path to a like Google Cloud bucket, and it's like here. So in our MLOps bucket, we have models. So in the models is the model.pickle file. If you see, this was created Feb 3. Now let's go ahead and rewrite this. It's copying the content, 69 MB, done. Here if you refresh, refresh. Okay. If you see like today's February 8:41, now we have again like have the this 69.8 MB. So our model is successfully now put on our main thing, like a GCS bucket. So this is the first step. If the data scientist has not done this job, they have to do this. You have to ensure that the model is there in the bucket. Okay. And then we need to check the model path if it is fine. So here is our model line. Okay. So perfect. I think with the model we have, so what our job is like to put the model in our, so right now we are following the MLOps level 0. Okay. So you are with me, guys? I mean, we are following the MLOps level 0. So we are right now in that team that is having a data scientist as a separate team, IT serving as a separate team. So we are a part of IT serving. So far, whatever you have seen, it's a part of a data science process. That's a training data science team. Now we are into this team. So we are preparing the serving environment now, and then we'll do the model deployment. Okay. So these are two steps on us right now. So we'll prepare the serving environment. So we'll use the serving container. Now this is a pre-built the container. Okay. You have a list of containers here. You can go here, can do a copy, and then I'll paste it here. This will give us all the list of containers that Google has created. Or maybe you will go on Azure or AWS, you will search, pre-built serving containers. You will get a list. In the Azure, it's a ACI, Azure Container Instances. You will have that. And they will have some pre-built images. You will have to check which image is useful for you. There will be TensorFlow, some scikit-learn, some framework, XGBoost. See, like, there are multiple frameworks. For our use case, we are using our scikit-learn model. So we are using the sklearn. That's a scikit-learn. And then sklearn CPU. CPU means if we have a machine learning model which is running on a GPU, this will be sklearn GPU, TensorFlow GPU. Okay, this is a compatibility thing. And then we are using a version. You need to 1-2 is 1.2, and then the latest tag. So if you have ever worked with a Docker container, you will have an entire URL, and then you will have a latest or some tag, v1, v2, some tag. So let me search this one for you. Okay, so we have this here. This is scikit-learn. We are having multiple versions. Okay, so if you see, like, again, we have the things here. Okay, so this is our scikit-learn. You have a CPU, we are using this image. Is it clear, like, from where the image comes now? Like, from where the image is coming for us? We are not building the image from scratch right now. We are reusing it. But what if, like, you don't have your, like, required version or some packages here? Like, what if I'm using something different than scikit-learn? So you will have to create your own image. That is what the advanced thing is. We'll look at in a later demo sessions where we'll create our own custom Docker images for the predictions or serving the model. Okay. Right now, since we are doing in a beginner level, we'll just use the, and most of the work in the industry will be done by this only. Like, there will be, like, in some cases where you want to optimize or want to use your own images with your own packages, you will have to create. But as you see, like, most of the, like, a PyTorch will be there, scikit-learn. So our job will be first to try working on a pre-built container. So the preference is always on a pre-built because it's optimized. Okay, these guys have optimized on the containers. Okay, and then what we'll do is MLOps 0 model notebook. We'll rename this, and then we'll put the model path. So we'll just run this cell. That is now creating a model, and then we are creating a model LRO. LRO is a long resource job. So basically, it's a long time taking job. That's why we don't wait. This is again we are using AI platform library, the model dot upload. These are the functions. AI platform, the library which we imported, right? On the top, if you remember. Remember, we imported one library on the top. That's from Google Cloud. So similarly in Azure and AWS, you will be having some library. In AWS, that's Boto 3 or something. So that's one library that you use. And there are multiple, SageMaker you will be having. So we'll explore all of that later. So, but understand the fact that you are pushing something in a container registry now. So if you see, go into the model registry, you will see that our whatever we have pushed like MLOps, zero model notebook, you should be able to see this MLOps models level model zero notebook. So this is a model, okay, and then you can deploy the model. You can do it from UI as well. No, in from a UI, let's say, click deploy to the endpoint, create a new endpoint.
एक मिनट फोन करता हूँ.
Hello, yes, somebody saying something. We
Sorry,
are only
my mic was not on.
okay. No worries. Yeah, we are only a few minutes away. Don't worry. Like, let me complete this and then we can close the session for today and then we can continue tomorrow. Okay, just wait for a few minutes. So we are on the verge of deployment a new model. Okay, so we'll have the endpoint name. Like the endpoint name is MLOps level 0 UI. We are using UI, and then you are using a. No, we are creating a new endpoint. If you already have an existing endpoint, you can click here. When having a new endpoint, click here. Okay. Then you will have a region. Because we are choosing the same region, we have to keep this region itself. So we have our model trained in this region. We have a model or registry, so you need to use the same region. It will not allow you to go into some other region if you see like, same region as your models. So model is nothing but, you are storing it in a metadata. This endpoint will be having another machine which you configure. Okay. So in a split, you have 100% split, 50%. No, you have a auto scaling. You have is it no scaling if you set a minimum one. So we'll set a minimum one node, maximum one node. Okay. And we'll say machine type, standard. It will say very small machine. Okay. We don't need a high machine. Nobody will be using our endpoint right now. We'll keep a very simple. So we'll service account, we'll keep a service default service account. Okay. And then you will enable the access logging for this endpoint. You have explainability. If you want to have explainability or no, then it will take like, some few moments, like, I think it will take 5 to 10 minutes. So you say enable the model monitoring. Okay. And then this will ask you much detail. So for now, we'll reduce it. This we'll see tomorrow, like, what is the model monitoring, how we'll see the demo of that. And now, once we click on a deploy, this will be taking all our data which you have selected here. Like, model setting, you have selected MLOps zero model notebook, which you have created from a notebook, and it will deploy. Let's see, let's click deploy. And in the moment it will reflect. So it will say that it's deploying a model. Okay. This is from the UI. Same way I can show you with the code. So if you see, this is a 3 line of code which I have blocked here. Sorry. Yeah. So this is one code that we have seen here. It's a very simple code here. Model.deploy. Model is our this model. Dot deploy is our function. Machine type, we are saying N1 standard 4. We have selected a smaller machine than this in the earlier UI thing. And the minimum and max replica will be 1. If you just, run this cell, this will deploy a model on this machine. But we don't want to create that, that will be again a repeated thing. So we'll pause it here, and then for tomorrow, this is a manual process. right now, which you have seen, this is this one, the which I showed you, right? We went through the entire process today, like by using the manual steps, and then we created, and the final model has been deployed. It will take a 5 to 10 minutes to come live, but it will come on an endpoint. You can also, hit that endpoint from your machines. Okay. So if you have another 5 10 minutes, we can see the, model, and then we can test it. But we can look at this tomorrow as well. Don't worry. I think we are already over time. So tomorrow we'll start, you know, like this is, the code for testing the this things. We'll not do it right now. It will take some time. So from tomorrow we'll see the pipeline code. From here the pipeline is. So if you see this code, this is like MLOps automation level 1. So this is a level 1 automation which we'll see the entire 16 cells. So in this, like what we are doing, we are importing Kubeflow, we are, compiling, or maybe, having all the things, and we are writing all the codes, right? So somebody was asking, how this flow is created, right? So this flow, which we saw, this one. So if you see download data, process data, train model, this is like, download data. Then we have a pre-processed data. Then we have a train model. All this is component. But underlying, if you see, this is the same code that you have done in the manual thing, right? If you compare this entire same thing has been done here. I can show you. Okay. So the entire same thing has been done here. If you see this one, this line, if you see this line, this is the same lines of code that we have run there. Okay. Yeah. So this is how we'll, do it tomorrow. Like we'll see everything. So tomorrow we'll start the session with the same thing. We'll start with a MLOps level 1 automation demo. And at the end of it, you will be able to, kick the pipeline. We'll submit the job from here and we'll show a new pipeline to you. Tomorrow it will run in front of you. Okay. And we'll see every detail, like, what all parameters that go if you go in a summary pipeline. These are all the parameters that you put it into a pipeline. And then there will be for every particular component, you will be having some input parameters. We'll see each and everything in detail. So it will take entire 1 hour for this demo. Okay. So tomorrow be on time, and then we'll start with this thing, and we can go ahead with the other things as well. Okay. I think
Thank
thanks for being patient, and yeah, if you have any questions, you can wait back, or maybe if you have any doubts, you can connect with me later as well. If you found this useful, any other questions or doubts you have? We are good to end the session. Okay, so I'm ending the session for everyone. Thanks a lot.